Uh, Hello. So today we will be discussing a problem that was asked in the Trilogy Innovations Open Assessment for SD Intern that was conducted on 6th August 2023. It was problem B, the second problem, and the name of problem was Is it possible? So basically the thing we are given in this problem is we are given a number A. We are given a number A that represents the number of days in a year, and we have to perform some type of work in a year. Basically there are m types of work to be performed, and for each work we are given a 2D array B, which tells us the information of that work. B basically gives us three pieces of information about each work. The first is that on which day will the work begin. The next is that the deadline for the work, basically before which day the work must be completed, and lastly it will give us the duration of work, that is the number of days required to complete a work. Now for each day from 1 all the way up to A, we can assign each day to one of the three categories. The first category is rest day, no work will be done on this day. The second category is the deadline date or a deadline day. That is, if this day is the end day, that is B of I1 for one of the works from I equal to 1 till M, or otherwise we are performing one of the works, so each work is like labeled with an ID from 1 till M, and we are performing one of the works from 1 till M, and we have to give the ID of that work. Now if it is the case that we cannot perform all the work before each work's deadline, then we have to return a vector of size 1, which is -1. Otherwise we have to return a vector of size a plus 1, where the first element is -1, and then for each element from 1 till a plus 1 till a, for each index from 1 till a, the element at this index is 0 if you are not performing any work, that is a rest day. Otherwise it is m plus 1 if it is utilizing second category, that is its deadline for one of the works. Otherwise it would be the ID of the work that we are performing. Basically ID is the index of the work from 1 till m. And one thing to note, that on any day there will be a deadline of at most one type of work, so it won't happen that two works or two tasks end on same day, have deadline on the same day. Also that if more than one type of work can be performed on any day, then we are asked to perform the one having the least deadline. So if a task, let's just say if work A and B can be performed on ith day, then we have to perform the work, or for now I will just say task because it's easier to say, task having the least deadline. So for example, if deadline, I will just say end to represent. So let's just consider the notation over here. So basically what's the information that array B is giving us? It's giving us this information: the start of each task, the end, that is the deadline of each task, and the duration of each task. So now rather than saying this B of I0, B of I1, I would say start of I is the start date of the ith task. End of I is the deadline or end date of the ith task, and duration of I is the number of days or duration of completion of ith task. Okay, now let's just we are considering over here, so if A and B both can be performed on some day I on the ith day, then which one we will perform? This line says that if the end date of A is less than end date of B, then we perform A, otherwise we perform B. Okay, and this also says that either end of A is strictly less than B or end of A is strictly greater than B. Both of them cannot be equal to each other. Okay, now basically this is an, in a sense, implementive problem. So okay, what we can do is that, so over here we can see that A is quite small. A is like 2 till 100, 2 till 100, so the number of days is at most 100. So what we can do is that we can start from like day equal to 1 till 100 or A. So let's just maintain an array called work, and work of I is basically 0 if ith day is a rest day, it's id if work or task idth task is performed on the ith day, and it's m plus 1 if the ith day is a deadline for like some task, which is basically like there is an task with index id such that end of id is equals to I for some task id, for some index id is strictly less than greater than equal to 1 less than equal to m. Okay, now basically what we can do is that from each day from a delay, before doing that, let's just this thing is something we already have, so before doing that let's just assign work of end of I equal to m plus 1 for each I from 1 to m. So for each of the tasks from 1 till m, we just assign this m plus 1 to their deadline dates. So basically we cannot do any work on these days that when each of the tasks have a deadline which was given in the question. Now what we can do is that from each day we start iterating from 1 till a, then we consider that is there any task that we can perform on this day. Okay, so when can we perform an task, let's say with id with index id on this day? Well, for that to be the case, the start date of id has to be strictly less than or equal to, it can also be equal to, so the task may be given on this day, so it has to be less than equal to this day, so the start day has to be less than equal to the current day, and the current day has to be less than equal to the end day, the deadline, the end day of this task. Okay, so what the problem says is not actually less than equal to, but strictly less than, because no one can be performed on this day, on the end day. Okay, so what the problem says is that between this start of id and end of id, we have to perform this task, and since no task can be performed on the end date, we have to perform this task between this range s till e of id minus 1, and we can only do that, means we can only perform this task on day on this day if this day lies in this range. And this range is basically that day is greater than or equal to s of id and strictly less than end of id. Okay, now that we have this, we want to find some way to basically okay, so now that we are up till over here, we want to find some way for each day. We have two questions. One, is there any task that can be performed on this day? And there's also a second question, that if there are more than like one tasks, which one will we choose? And actually finding this thing is quite easy. We can just maintain all the we can just like, since we are going from day 1 till day A, we can sort all these tasks by their start dates, and we can maintain a pointer like, so we can just sort all these tasks by their start dates and all the way up till here, like day of M. So initially the pointer would be over here, and then we decide, okay, we want to include this task, and then the button shifts over there, and we say that okay, this start is strictly greater than day, so we stop over here, and then we go from like this day to day d plus 1. We'll once again check, can we include this task 2 now, and so we can go so on so forth, like we'll keep a pointer, start from a pointer over here, and then for each day we'll check, can we include s1 now, because like s1 is less than equal to day d. If we can, we move our pointer to the next guy, that is s2. We can check the same thing for s2 and go on so forth. Okay, now so dealing with the first question is like quite easy over here. The problem is dealing with the second question. Which day are we going to choose? If we have which task are we going to choose? The question actually answers this thing. The question says that if more than one type of work can be performed on any day, then perform the one having a deadline first, means one having the minimum value of end of I. So the answer to second question is perform the task with minimum value of end of I, end of id, where id is the index of task. How can we do this thing now? So basically what we do is that we iterate. Firstly, we sort tasks according to the start index. Then we go from day 1 to A, and we want some way in each iteration to like get the task with maximum, like minimum end of I. So for that we maintain a priority queue, sorted by end of I. And then for each day from day equal to 1 till A, the first step that we have to do is add all tasks with start of I less than equal to this day. The second task we have to do is that if the priority queue is not empty, then perform the task with minimum end of I, that is the minimum deadline, that has deadline first before any task, and also decrease its duration. Okay, so I think that was pretty like a straightforward implementation based question. So let's just go to the code to see exactly what's happening. Basically the part below here, it's taking input and just getting this array getting this number a, m, and the array b. If we go above over here, we can see this is the main function. Over here what we are doing is basically we are making these arrays start, end, and duration. And I have actually defined two priority queues, PQS, that is priority queue of start, and priority queue for end. So basically priority queue for start stores this pair start of I and I, where I is the ID of task and start of I is the start date of task. And also this is the vector array answer. Basically we used work array over here, but I have written it as answer, and this answer array is being returned over here. Fine. Answer of 0 is -1. This was given in question, no really reason for it, but fine. And boolean is possible. So this boolean variable actually stores, is it actually even possible to do all these works with the given constraints. Okay, so then we go on iterating from day 1 all the way up till day A, the total number of days in the year. Now, what does this line of code do is that while the priority queue of start, this pair start day of I and I, while it is not empty, you can see over here that it's actually a minimum priority queue. So the top of this queue will have the task with minimum start days, so which starts earliest. So while this queue is not empty and the day with minimum start day is less than equal to day, that is, the day with minimum start day starts before this day, what we do is that we remove this element from this priority queue. So this whole three lines do is that they remove this element from this priority queue and we push this day into the priority queue end. Basically, we push this day into this priority queue for end dates. The first element is the end date or deadline of this day, and the second is the ID. Now, if ans of day is equal to m plus 1, so this day is a deadline for some of the days. So according to question, we can't do any work on this day, so we just continue. Otherwise, if the priority queue end, so if there is some task that is active currently that we can do on this day, current day, then what we do is that we remove the task that is at the top of this priority queue end. What will be at the top of this priority queue end? The priority queue end is sorted by these numbers. The end of ID is deadline, so the day at the top of this priority queue end will have a minimum value of end ID, that is, it will have the least deadline. So we remove this task and we just assign this task to this day. So we are going to do this task on this day. And also there's one other thing that we have to check, that is it possible to do this task on this day. If like the end day, the deadline of this task has passed and this we have come ahead, then it's simply not possible to do this task and we break the loop and set is possible to false. Otherwise, we decrease the duration of this day, so it was going to require some number of days to do this task, and we have done this task once for 1 day now. So we are going to decrease the duration. If duration equal to 0, so we are actually done with this task. Okay, if duration is not equal to 0, so if duration is not equal to 0, we are yet to do this task. So we are going to push it into priority, we are again going to push this thing into priority queue and we are going to continue. Now at the end of this whole loop, if the priority queue of end and priority queue of start, one of them is not empty. So basically, when is priority queue of start not empty? When one of the task was like its start date never came, in that case. And priority queue of end is not empty when there was some task which didn't get enough number of days to complete. In that case, we set is possible to false, and if it's not possible to complete all works, then we just clear the answer array and assign it to a single element -1, and we just return this answer array. Okay, I think that's all, and thank you for sticking around.